Well, thank you. Thank you for coming. And hey, there's two more people, so now it's just not
Well,
the
it's official.
presenters. Thank you very much.
We got all more coming soon. All right, you might need a microphone.
I'm actually a PhD candidate. I should graduate a year from now, actually in December 2017, thank God, because it's been a very long road. But my topic is the structured analysis of SQL injection runtime mitigation techniques. I'm presuming everybody in here has somewhat of an idea of SQL injection, so I'm not going to cover it in detail. My major advisors are Dr. Jim Alice Foss at University of Idaho, and Daniel Conte de Leon, who is in Nashville, Washington, D.C., and he couldn't be here with me. So, quick outline, I'm going to give you a quick introduction, some terminology, a little bit about SQL injection attacks, just so we're all on the same page. We're going to talk about all of the SQL injection attack mitigation techniques that have been done in the last 10 years or so. We'll then apply formal concept analysis, which is nothing more than a fancy way to say set theory, to those mitigation techniques in my classification system. From there, we'll identify two that will be potentials to move into practice. So when I came on Wednesday, there was a conference talk about technology transfer to practice, TTTP, because a lot of things like SQL injection are researched and then they go on the back shelf after we get our PhDs and go on to teach or whatever. So that's what number 4 will be about, will be transferring technology to practice. And then number 5 will be how we're going to transfer technology to practice using a product that we're developing at UI. So, quick overview. We know that there are over 1 billion web pages now in the world. We have no idea how many of those are insecure. Old technology, 2,000-year-old, made in 2000, never updated. Some back-end shopping cart, no idea what the technology is. SQL injection, we all know, has been solved. As we teach, we always teach SQL injection, how to solve it. The problem is, it's still the #1 vulnerability on OWASP. And they have a publication that they update daily with every new SQL injection, and there's at least 5 every day on that list. So what do we know? We know that most of the developers out there, and I have the demographics to show you in a minute, are inexperienced and untrained. They go through, they pick up a book, learn PHP in 24 hours, and it says nothing about SQL injection. You go on Coursera and you learn how to do the web programming. There's just a very small little blurb about SQL injection and nothing else. So most of them are self-taught and inexperienced, and they don't have any idea about how to do secure coding techniques. So what are our choices? Well, our choices are simple. We can rewrite the web, right? Let's all rewrite the web. Let's start now. That's not feasible, obviously. Obviously, we want to teach secure coding techniques. That's what a big portion of this conference is about. Cybersecurity, secure coding, that kind of thing. The problem is the number of jobs outweigh the ability for us to graduate those number of people. So we need some kind of low-level, configurable, runtime type of protection similar to ASLR or StackGuard, something that we can just drop in that's going to take care of a good majority of our problems. So, 2006 is really when SQL injection took off with Helifon, Viavis, and Orso. They really classified it, and then they came up with those 7 categories. And then, of course, the body drop tables that we're all familiar with from XKCD. But really back in 2006, when Helifon, Viavis, and Orso came up with those categories, that's really when they gave SQL injection credibility. So what we did is, to start with, is we went back to 2003 and we said, okay, what has been written about SQL injection since 2003? And it's actually more around the 200 papers. I only scanned through, read in detail 120 of them. Those papers can be actually classified into 3 categories. completely a solution that is static analysis. Let's write the code, we'll run it through some static analysis thing to tell us where the SQL injection can possibly happen, and then we'll go back and fix the code. We have completely runtime. A lot of work is being done out of Syracuse with tainting. Let's taint the transaction as it goes through the SQL engine. If it gets untainted, then we'll consider it fine. If it's still tainted, then we'll throw up a 404 error. So there's completely runtime. And then there's a hybrid of, we'll write the code, we'll look at it in the analyzer for the static side of things, fix all those, and then we'll run it through the runtime analysis, and then hopefully that the tagging or whatever will catch it for us. So where we focused really is at the runtime analysis. We want a drop-in tool similar to StackGuard, similar to ASLR on a Linux system to prevent buffer overflows. We want to make a tool very similar to that. So we can just drop it in, people can use it, they don't have to worry about it. It's not going to mitigate 100% of them, but it's going to mitigate a good portion of them. But you can still obviously violate and do buffer overflows on a Linux box, but it's more work. So just some demographics, taken from Stack Overflow, but I have other stuff from other stuff from other sources. You can see that in the 2016 survey from Stack Overflow, they surveyed all the developers out there, 69% are self-taught. Okay? And a lot of that, again, then comes from on-the-job training. Now, obviously, these numbers don't add to 100 because, it's different people selecting different categories. The most telling is you have a very small number that have a degree, a formal degree in computer science. Most of them are self-taught. I was actually at a conference in 2012. There were 300 people in the room. They asked how many people were actually classically taught in web programming, and all but like a dozen hands went down. All the hands were up as web programmers, but all but 20, 25 hands went down because everybody else was self-taught. One of the other things is, again, most of them don't have formal education. From IEEE Institute, most computer science programs skip cybersecurity altogether, skip security coding techniques. ABET is just finally released the standards for 2017, and there is one in the A through K, if you know anything about ABET, that talks about information assurance. There's one bullet point now in the 2017 standards for accreditation that talks about information assurance and cybersecurity. That's it. In the 20 years I've been teaching, there's now one bullet point on cybersecurity in the ABET standards. Okay. And then again, here's the demographics of the jobs. There are currently 186,600 open jobs for developers. We can't produce enough computer scientists for that. And then the demographics for JavaScript, where they're at, that kind of thing. And then for the most part, most of them are full stack developers or back-end developers, with a good majority being students. But even, there's less than 10% for each of the categories for mobile. It's still a major for a full stack developer. So how does this relate to what we're doing? So what we did was we said, okay, let's take all those SQL injection techniques that were in the last 10 years, and let's classify them as hybrid, runtime only, or static analysis only, and let's apply formal concept analysis to them. Let's take them, apply mathematical principles to them, do some thresholding, and let's see what we come up with. That's exactly what we did. So, we created this two-dimensional array, so to speak. Over here you see the SQL injection that Holofon et al. Came up with, and then we identified these as the major attributes that are important to us for a drop-in tool. So for example, we don't want high programmer involvement, right? If we want to have a drop-in tool, we don't want to have high programmer involvement coming back and telling us we need, to look at the code again. When we run it through the formal concept analysis we come up with this tautology, or not tautology, this lattice. At the very top here is just the starting point for tautology, and then at the very bottom down here, which is very washed out, you can't see, are all the different runtime mitigation techniques that we identified. So what you get out of this is nothing really fancy that you can just see at a glance, but it tells you, hey, based on these inner nodes, the blue and the black, which one of these are the best to move from research into practice. And if you look at that in this fashion, you can see that it comes out to be over here WASP, which is a Hall of Fame product, and web application firewalls. So web application firewalls are actually newer to the scene than WASP is. WASP is a purely runtime technique. But if you go back to this slide, you can see that it identified two products, WASP and web application firewalls. Currently, RASP is what it identified. Currently in production is a product called RASP, which we believe is an offshoot of WASP. And then web application firewalls are open source, so we're going to focus on the web application firewalls for a couple reasons. Number one, by their own admission, RASP is only available for Java virtual machines and the .NET Common Language Runtime, right? Well, that doesn't help me when a majority of the web pages are written in PHP as a drop-in tool. Plus, it is very, very new, and it's commercial, right? Well, yes, it has made that transition, we think, but it is a commercial product, and we like open source. So we're going to focus on web application firewalls. As we know, web application firewall is an application firewall that applies a set of rules to the HTTP data coming in. It's very good for SQL injection, basic SQL injection. It's very good for basic cross-site scripting. Mod security is the most common web application firewall. You have to actually turn on the SQL injection rules. It's not actually on by default. You have to go in and configure it to turn it on. Great, it handles the basic tautology and all that, but anything more complex then becomes a nightmare. So this is a mod security rule. Okay? This is a mod security rule to handle a little bit more than tautology injection, you know, 4, 1 equal 1 type of thing. I don't want to write this by hand, right? The whole point of this is a drop-in tool where a programmer does not have to have high involvement to be able to write this rule. So our research question really then became, mod security rules are really difficult to write if they're more than just the basics. So is there a high-level security specification language that is easier to use? And if there is, will that language allow us automatic page generation or automatic web application firewall rule generation? And in our case, there is. Okay? Our case is called Hermes, which stands for High-Level Easy-to-Use Reconfigurable Machine Environment Specification. It was originally built out of a graduate student, a master's student at U of Idaho, trying to configure web browsers. He wanted to do a system-wide change of, hey, I need to turn off JavaScript on all these web browsers. Let's look at the three, you know, Safari, Explorer, Firefox, and Chrome Explorer. Found out very quickly there is no common term among those web browsers that says, here's the JavaScript on it. Okay. From there, we took it into more advanced, so we have a grad student that's working on using Hermes to create the web browser configuration. We had a grad student who just graduated who used it to configure Cisco routers. We had another grad student who just graduated to do it to configure SE Linux, and now I'm using it in modification to configure web application firewalls. So the idea is I come in as a programmer and I say I need to write a rule to handle this PHP page for SQL injection. All I need to do is write this high-level language like that, run it through the Prolog compiler, and then it spits out the rule for me automatically without me having to go back to this rule right here and try and write this as a complicated rule by hand. So the idea is Hermes will be able to generate that rule for me, and everything will be good, and then we can just use it as a drop-in when we have something more advanced than just a simple tautology exam. They have Mod Security actually has a competition every year, and they just published the latest 9 hacks that they found. It took the average person or the hacker somewhere around 100 hours to find the hack, and it was 128 characters long with the tautology attack, and it was a tautology attack as hexadecimal at the very end of that, because originally the mod security rule set only stopped at 120 characters. So they went just beyond that. They showed how they had to fix that security rule, and it was just a nightmare. It took them like 2 weeks just to fix that one rule to handle that one tautology exam. So, 3 minutes? Okay. I'll take questions then, because I'm pretty much done that way. Questions?
Are these things running?
It's starting to run. I'm still trying to get it all configured out and running so I can publish on it, so I can get my PhD and go back to my full-time job teaching Eastern. So,
Your slides available?
yes, I will.
Because I'd like to use them.
Yeah, absolutely. I'll happily send them to you. Yeah.
I want to go back to your premise about, practice what we preach in cybersecurity education in computer science departments, and I feel like all too often, proper documentation, things like that, we do a good job of talking about software engineering, but far too often I think security is one of those, you'll take that course later.
Yes.
And it shouldn't be secure coding, it should be coding which has security practices woven into it. But we're talking about academia where everyone has their own perfect topic that they love to study and they don't care about anybody else's. So how do we change departments so that it's not go take your security course at 300 or 500 level and kind of retrofit your knowledge, because students will do what they're taught. How do we get it integrated into 100, 200, 300 level programming courses?
It really comes from, that's a great question, it really is. And I teach, so it's interesting, because I teach at Eastern Washington University, that's my full-time job. And I teach the beginning Java 1 and the beginning Java 2. And then I teach the operating systems. And very much in the operating systems world is, I am not going to break your code by throwing spaces and crap at it. We're trying to emulate the scheduler. Let's just worry about the scheduler. The only thing, and I've said it 1,000 times, you take secure code later on if you want to understand the other side of things. But at the 100, 200 level, I really think in my department, they have made a concentrated effort. I have a software engineer who's good at security principles. He has been mentoring me along the entire way, and I have completely changed the way I teach those beginning programming classes. I'm actually now doing all test cases. So I do both, provide them a main to run their code, but then in class I also give them the test cases. And they do now both. So they're starting in now to implement that. The problem is I only teach those one time a year. There's another teacher that's getting ready to retire, and he's not going to change. That's just, so. I think that conversation has to happen at that low level, and you just kind of gotta hope, but there is no magic bullet, unfortunately.
Yeah, I have a question, because we are not only having SQL database, okay? We
Right.
are like an Android, non-SQL. So when you surveyed all these mitigation techniques, did you think about some of them can be used to non-SQL? Because we know the attacks are very common.
Right. Yes, part of that is like MongoDB and others, and there's a big, I absolutely did, and there's a big push into the cloud too. Now a lot of the stuff's going up into AWS, into Azure. How's that going to affect it? The concept here is, if we can intercept that traffic ahead of time, doesn't matter what the database says. If we can identify it through the web application firewall, we should be able to mitigate a good majority of it.
Okay, did you get a chance to validate all those mechanisms, or you just did the survey? or what? do
I
you
actually went through, I didn't validate all of them, but I validated a good majority of them. And hopefully I'm gonna turn that into a journal paper. I'm gonna take this talk and this paper and expand it into more in-depth research with those, validation of those, and turn it into a journal paper for this
Correct.
conference.
So you definitely need to meet the editor this afternoon. The
Yes,
journal paper, yeah.
Yes.
Correct.
other questions? Well, thank you.
Okay, the second speaker is